But we have been working on wireless mobile networks for more than 20 years. Sensor networks, progressive computing, EV computing, and then with industrial response networks. Very important topic. What you see over here, my department is celebrating the 50th anniversary of computer science, which started long ago, and it was a jubilee year for us. And going forward, our department theme is smart computing. That's what you see on the right side as well. Now, I'll start my talk with a quiz. Because the bad habit of being a teacher is that you give exams, you give quizzes, and it's very difficult to get rid of that. So let me start with that. How many of you use Twitter? How many of you use Facebook? Very more, right? The Twitter is also used in government and offices as well. So the first question is, who is the founder of Facebook? You also. Who is the co-founder of Twitter? Twitter started much earlier. Facebook basically took off with more than 1 billion customers now. Facebook is still struggling. But I would like to bring in the context so that co-founder of Twitter is Jack Dorsey. Why do I bring it over here? Jack Dorsey was student in our department in the 90s. He did not finish his degree and then he started this company and all. But another context over here is Twitter is also a very good technology for research. You know, and in Uttarakhand, there's a plant and all. Actually, Twitter blogs were extremely important to decide a lot of things that are happening. The social media information dissemination is so fast that you can take care of many things. We'll be talking about networking and all, but when the network gets disrupted, often it is social media and your Wi-Fi connectivity on your smartphone actually becomes saved. Okay. So now let's get a broader perspective. Disaster response is not just natural calamity or terrorist attack type of thing, it's much broader. So let's just give the context first. So let's look at the societal grand challenges. What is the objective of this science and engineering or technology? Is to help the society to advance, to improve our quality of life, to have secure, safe life for the citizens. Right? That's of course goal. And with that in mind, so let me just pick 4 themes which are true across the globe, irrespective of the national boundaries. So these are the societal grand challenges we are all working hard to solve. Energy and sustainability. So energy and sustainability is very important. Takes care of the energy, water, and this is how ICT is contributing to technology. The backbone technology that we use in that environment. Security is not just a nuclear message or securing lives, securing assets, securing buildings, infrastructure. Security is information security. We talk about cyber physical security, the physical environment. We monitor and we have data and we want to install the cyber and there is strong interest in that. National challenge for any country. The aging population is all we talk about body and then also the last one I characterize as extreme event management. The extreme event management actually will be the theme of this particular realization. Natural disasters as well as man-made disasters. So both. Let's give a broader context of this. For example, if there is something on the street because there is an accident or somebody who is now, natural disasters, of course, is not our control. Often we have so we have the system is warning to give early warnings and alerts. Most of them are category 3 hurricane and become like category 5 and this is just some example. I think the few examples here from this year. there are lots of statistics there. There are more than 280 million people got affected in the last 20 years. And on the average, 1.2 million people not survive. Just think about it. And a collapse rate is there, Uttarakhand is there. And then you have inflicted disasters, man-made disasters. Could be whatever. What happened in Turkey, what happened in Mumbai, what happened in 911, and also actually manipulate the body and election. Right? I don't. So, these things, of course, the first one is longer control. Second one, of course, is often longer control because human mind is so ingenious. There is a lot taken a different way, right? But keep that in mind. Some question is what to do. So one aspect I'm keeping the theme, but in the next few slides I'll actually go beyond that, or I'll expand on the theme. So theme was next generation wireless network and disaster management, right? So one important criteria in any disaster that happens, either man-made or natural, that is communication systems most of them get affected. Communication infrastructure. There's a typhoon, there's a hurricane, flood, earthquake, communication is gone. So that's one part of it, right? And I'm giving some statistics from Nepal last week that happened on last year. Right? And you can see that how many cellular sites were actually down. About 35% or so. Cellular sites were down. And then when that happens, then there's a cascade effect. The electricity goes, and that electricity goes to because of water.
So communication infrastructure is extremely important. If that breaks down, then we are out of luck. And we'll actually give some synopsis of what are the effects that we have if we lose the communication infrastructure. So basically the primary goal of any disaster response system is to establish a very reliable communication infrastructure on the spot. Most often we call ad hoc. And that should be very fast and very prompt and reliable. Yes. And advantages are of course enormous because if we have that, then I can do efficient rescue and relief operations. Right? I can find people who are under the rubble, who are affected. You can do rapid evacuation. You can also get in touch with the family, friends, or whatever. So these are the things that you need, right? But at the same time, disaster management itself, communication infrastructure is just one part of the problem. There are lots of things that one needs to do. For example, actions that you can take before the disaster, we call pre-disaster management, so that I'm ready for any events that happen in future. And then when things happen, then of course you also have to. So how do you recover from the situation? How do you offer relief rescue services? On this timely manner. So people will be sheltered, in camps. All these things will happen. And then public health becomes at stake as well. Water contamination, all this. So if you see in a broader perspective, disaster management has lots of matters. And a country can actually suffer several months and years to be millions and billions of currency lost. This is a very quick synopsis of different requirements of communication infrastructure that you want to establish. I'm not going into the details. So first of all, it has to be very easily deployable, cost effective, very fast. And also, since nowadays we talk about very powerful device in your hand called smartphone or cell phone, whatever, they are battery operated. So you want to make sure if they are communicating with each other, then energy can be saved. So it is not very energy efficient. And that technology has actually created a tremendous advantage in the society that we know, including disasters. So this can be identified because I can detect signal that somebody is still there alive. It's almost like a heartbeat that you can hear. So various communication mechanisms that can be set up on an ad hoc basis. It's a long time, for more than 30 years, mobile ad hoc networks have been used. But lately people talk about DCN or delay power network, which is also called opportunistic network sometimes. Opportunistic means For example, I have a bunch of cell phones over here, and or smartphones, can I communicate among themselves in a peer-to-peer manner, right, to the Wi-Fi? So that's the kind of ad hoc infrastructure that I can set up. And also, so opportunistic basically means that you have unused bandwidth which is lying around and not used. Like, can I use them to set up something? And the combination of ad hoc networks, opportunistic networks, the VPN and cellular networks, called hybrid. And then lately people are also thinking of just like TV white space, because the spectrum is not used most of the time. Although we spoke about wireless network has a tremendous shortage of bandwidth, but many bandwidth is not used properly. The question is that can I take use of that? This is the dynamic spectrum management. So just quickly, what does delay tolerant network mean? DTN, in case you are not familiar with, it's basically a store, forward and store, carry and forward type of messaging scheme. So I have some information that I want to as a source, and I want to forward that information. Somebody else stores in between and forward, carry and forward. And then lots of different research is going on for last maybe 15 years or so in DTN, mostly 1999, 2000. When Mikola actually wrote a PhD thesis on DTN, and since then a lot of work is being done. And you can see that how I can use the smartphones or the mobile devices in a device-to-device communication or machine communication mode to set up impromptu an infrastructure. Although the cellular infrastructure is gone, but the Wi-Fi facility that we have in the devices, I can use them to create a network. And hybrid architecture, of course, some things are getting cut off over there. Dynamic spectrum access is there, hybrid architecture is there, which is a combination of cellular. Sometimes, if you work with any of the emergency agencies, emergency personnel agencies, they have actually on the truck some kind of base station type of thing, just like the drop boxes they call it. From the drones nowadays, they can do it. From the helicopters, they can do it to a temporary base station, and then you create an infrastructure and temporary infrastructure. Things are getting a little, I think, because of the poly laptop or whatever. So, what I want to see now, the disaster response, I want to treat disaster response as a system. It's an event, but that event actually leads to a system we call a cyber physical system. What is the physical part? So, if it's a natural calamity, then environment, nature is the physical system. I want to monitor the system through devices, sensors, to collect a lot of data, seismic data, flood, water level, or let's say there's a pollution, there's a traffic, or whatever. So I can actually monitor the environment of the physical system and collect a lot of data. So basically physical to cyber. If it's a attack scenario, either a cyber attack or physical attack like terrorist attack, in that case that attack itself is a physical thing. Somebody is using a gun, somebody is, let's say, putting a bomb on a building or whatever, and then of course how can I detect that? So what a cyber physical system, if you can read, I'll just read it because the red part is covered up now. A cyber physical system is a natural or engineered system. Natural system is nature, human body. If I talk about smart healthcare, engineered system is this building, that airport, that hospital, that school, engineered system. And I integrate sensing. I have lots of devices to collect data, communication or the networking. Then what do you do with the data? You do a lot of computation, do data mining, data analytics to get some information out of it, so you can make an inferencing. So that's the control part, and also most of the human in the loop. Because there's some decision maker. Sometimes you make autonomous decision. Sometimes you have the human who are taking the decision, take the next action. So basically, it's a collaboration of different types of technology, and underneath lots of fundamental research issues and challenges. Okay? And I've listed some of them. The sensing part is there, wireless networking part, pervasive ubiquitous computing, and then intelligence control, human in the loop, and lots of middleware services. And each of them actually is a research topic. So you can talk about the device-to-device, machine-to-machine communication. You talk about different types of networking technology, pervasive computing, sensing, reasoning, and controls. I'm sensing some data. I'm doing an analytics on that, which is reasoning part, make some inference. and then I take a control action. So, and that loop actually is extremely important to learn how to take care of a situation. Then cyber physical system is a macro level concept. Nowadays you also hear the topic IoT, Internet of Things. And every object is now connected to the internet. Right? So IoT is basically a micro level concept of a bigger concept which is cyber physical system. So in my opinion, cyber physical system and IoT, they are very much interrelated. One is a macro level concept and is a micro level. So sensing creates a significant synergy in cyber physical system. One application is extreme event management or disaster management. Sensing gives us extra power. Sensing is not new. From the dawn of human civilization or the living creatures, we have the sensing organs, five sense organs, right? But the wireless sensor network gives an additional power to augment our sensing capability with respect to visualizing the whole environment. For example, I can monitor the flood, water level, I can monitor the breeze condition, I can monitor the health condition of a building, I can detect seismic vibration, I can detect onset of a hurricane or typhoon or whatever, right? Because I have these devices which can collect lots of data. Now, there are many things that needs to be done as a part of pre-disaster scenario as well as post-disaster scenario. The pre-disaster scenario is basically you're collecting data, you are making predictive models so that you can prepare a situation, how to handle a situation much better, right? But often we are helpless because things still happen, no matter how much models we have, how much data we have collected over the years, how much ephemeral data we have, but still we are helpless because things happen in nature without our knowledge, because things just pop up. So whatever it is. Right? The post-disaster, of course, we do lots of, and one part is, of course, fast and effective communication, which is the theme of this particular session. But then most important thing is the decision making. When things happen, then multiple units and organizations are involved. We have, let's say, the flood and hurricane that we had in Chennai. So city level is involved, state is involved, nation is involved. See, different units and organizations, even though they are handling disaster, they are handling different things, but they have different protocols. Communication, making decisions fast is extremely important to save lives, save assets. But most often actually fail in that because sometimes the protocol delay actually kills the whole situation. And this is true for every country. Because we will make the decision. What needs to be done? But these are the decision making that needs to be done. So an emergency response, for example. So this is a true picture when Hurricane Katrina happened in US in 2005. This was in Louisiana, in one state, and the neighboring state was Texas. So from New Orleans to Houston, the traffic was delayed by more than 24 hours. Everybody was stranded because everybody was on the road. They are fleeing away from the disaster situation. You can see that you create a secondary disaster. So people are just stuck. They don't have food. They cannot go anywhere else. And if the hurricane actually moves to their side, they'll all be killed. Right? That's the real situation. That's this thing, and you can see that how the situation awareness is extremely important over here. How do you assess the situation? And you can see that the emergency personnel carries lots of gadgets nowadays. So human becomes a sensor in addition to our own sense organs, because human becomes a device. You communicate with everybody else, you take decisions, you do that. So what are the research issues and challenges? I'll keep at a higher level again because of the heterogeneity of the audience that we have over here, which is good. Because disaster is an application where we need help of scientists to do the modeling and understanding the nature and physics. And of course, engineers and technocrats. We need social scientists as well, because when humans are involved, the psychology, sociology is also involved. The question is how do you establish fast, reliable communication? not only among the cellular towers or the devices or the smartphones, but among people as well. That's why I said first responders, Red Cross, non-governmental organization, NGOs, no, because they all are jumping to help. Right? So human is part of the loop. We have also ICT technologies which are playing role over here. And then heterogeneity, as I mentioned, the different protocols. The protocols could be different for different technology, different computing paradigms, but different organizational units as well. How do you set up a communication infrastructure impromptu or ad hoc? How do you make that situation aware? Because you only see what is happening locally over here. So when a natural calamity happens, that's a time varying phenomena that moves very fast. What you see right now over here, next instance it moves somewhere else. Right? It's very difficult to keep track of the pace at which the calamity happens. Same thing with man-made disaster like terrorist attack. Think about the Mumbai attack. What happened in the Victoria Station? What happened in the Taj residency? Sporadically things are happening and you only have a local view. You see this and you do not know what is coming in the future. And that's a huge data mining question. How to find hidden correlation among seemingly uncorrelated events. Think about how to find hidden correlation among seemingly uncorrelated events. Because you think things are local, very sporadic. You do not know that this has a relationship with something else. Because you do not know what is coming in the future. Extremely difficult to model. Okay, so that's a huge data analytics question. And then of course you are dealing with lots of Internet of Things, devices, machine to machine, device to device communication. Lots of interesting research, fundamental challenges are there. And then human is also coupling with those devices and technology. What is actually most important thing is that there is a huge amount of uncertainty. As I mentioned, like when things move at a very fast rate, that creates a lot of uncertainty around it. I do not even know which resources are available, which services are available, what kind of services do I need to provide a better rescue and relief operation, for example, right? So think about it. So situation awareness is the key. So in a disaster management operation of the services, lots of things that need to be done. First of all, need assessment. How severe is the situation? Assessment of the need, because sometimes that could go months and years because the damage is so severe. You talk about the assessment of the situation and also what kind of resources that you need. Human resources, physical resources like shelter, food, blankets, medicine, for example. And then of course you get lots of epidemic and endemic effects after that because of the public health is at risk. So multiple different reasons. So again, if I just elaborate based on the situation awareness or context awareness is the key. And in computer science, in pervasive computing, in mobile computing, we have to always deal with that. The situation is not just one event, right? So collection of events with a semantic interpretation underneath defines actually a situation. How severe is the situation that I need to take care? And again, as I mentioned, that how to provide a better decision support system when situation is evolving dynamically and there is a complex interactions of different units. Interdependence is really important. For example, a disaster happened, electricity went off, suddenly street lights are not working. Think about the cascade effect that can happen, right? And the bottom line is how do you save life? How do you save assets? How do you save infrastructure? So basically, it's a resource recovery service, lots of computational problems, lots of interesting challenges that are there. I'll just pick a couple of problems that we have been solving. So this is one of my PhD students who finished thesis a couple of years ago. His PhD topic, the theme was energy aware disaster recovery networking under Wi-Fi filtering. That means your cellular infrastructure is gone, it's disrupted. Only what you have is Wi-Fi connecting on your mobile devices. And how can you take advantage of that scenario to create an impromptu network to provide relief services, to provide evacuation, to detect victims, because of the device that you can recognize signals, so you know somebody is under the rubble, somebody is hidden behind the walls. Then another work, a current student actually is working, and he is from Nepal, but he studied in NIT Durgapur. So I sent him as soon as the disaster struck in Kathmandu. I actually asked him to just go and collect data. So he collected lots of interesting real data, of course collected by other agencies, and he also interfaced with them. So we developed some kind of not just the networking, but also how to send information around this network, because relief rescue operations also require how fast you can communicate, which we call networking terms the packet delivery ratio. How do you save energy of these devices, because somebody is under the rubbles in the earthquake, and it may be 5-6 days before somebody is identified and detected and rescued. So cell phone must live that long. That means it should not just keep on sending information, and you should not route information to drain out the battery. So you have to make energy efficient solutions. So we actually have been working on that. This particular research is very current and is under review right now. A very interesting set of topological properties that you can explore out of it. And without going into the details, so basically the objective is that how do you select in a hierarchical manner some subset of nodes which can actually work as responders. Responder could be the physical human being who are the rescue operator, or it could be a network node which actually is acting like a responder. And how do you make sure that your packet delivery ratio is very high with a minimum latency, and you also save the energy as best as possible. Lots of companies are actually working on designing effect technology based on either LTE or Wi-Fi or whatever. And as I mentioned that that my student actually collect a lot of data, and a lot of data is also available in the public domain from the Nepal earthquake, and we have to use that to validate our model, so that we have some testimony of that the technology that we are developing, solution we are developing has some meaning and impact. Some graphs over here, you can see the packet delivery ratio, packet overhead. This is the packet delivery ratio PDR, that's the packet overhead, and how much time does it take. And by neighborhood size, we mean actually we want to minimize the number of these responders, that we call cluster head hierarchical cluster domain, so that only few of them actually will be acting as cluster head or the responder, so that you can save the energy as best as possible. So I'll actually leave a lot of time for questions. So disaster response, as I mentioned, is a cyber physical system. It's no longer just a physical phenomenon, but it's a cyber physical system. And also human in the loop. Sometimes it's a cyber physical social system. So the social media plays a role. Mostly the Twitter feed, lots of blogs on the web. But measuring any system that you develop, which is temporally and spatially varying phenomena, with lot of uncertainty, it's very difficult to assess the success of such system, because for one system, for example, let's say there is a fire, there is an attack, there is a natural calamity, you develop a system, it works very well. For another event, it may not be as good, because the event is completely different in nature. The kind of data that is generated and collected is completely different. So that's what actually this particular picture shows, that measuring the success of such system is extremely complex. And the social science is involved over here, because as I mentioned, when human is involved, psychology and sociology of people and human dynamics also plays a role. I'll give you an example. So we organize a conference every year called International Conference on Distributed Computing and Networking. So in fact, it started today in Hyderabad. So I'm leaving tomorrow morning for Hyderabad for ICDC. And so one time actually we organized a panel called Role of Distributed Computing and Networking in Food Delivery or Supply Chain Management, right? So Food Corporation of India chairman, Mr. Burelal, actually, we selected him as a panelist. And he gave horror stories. He said that beyond this type of rescue operation, what happens? There's smuggling. For example, government sends from the godowns truckload of food and blanket. In between, it gets smuggled. There's a scarcity, and you don't have any more stock. And So smugglers are getting at a zero cost and selling in double the price to the government, and government has no time to deliberate on it because you have to save the life. It's not like, okay, it is your cup or why did you get it type of thing, right? So just think about this kind of dynamics is also involved, and things happen like that, right? It's a practical problems. So I'll be summarizing my talk. This is a famous quotation. I think Abhishek is laughing because he has seen this one probably. So we are all in academics. I'm assuming most of you are in academics or in industry, but still you are involved in research and thinking and all. This is a very famous quotation. I like it. I use it whenever I get any opportunity. Every course I teach, I also give in the first day in the syllabus. This is a very profound definition of teacher. Now I started my talk with a quiz. That was probably a difficult quiz, but this is a quotation that comes from India. Some writer in India, so I would like your answer that whose quotation is this one? And if you just read, it's a beautiful quotation. A teacher can never truly teach, unless he is still learning himself. So teaching is not just one-way communication. In networking, we say bidirectional communication. From this side, this one-way, not half the full duplex communication, right? So it's not just information dissemination from this side, but the other side as well. A lamp can never light another lamp unless it continues to burn its own flame. The dissemination. A good teacher, master teacher, always produces master student, right? And the teacher who has come to the end of his subject, who has no living traffic with them, they can only load the student's mind, they cannot weaken them. I mean, are you able to inspire the students in the class, or are we just repeating the lessons that are there in the book? That's the whole question, right? Whose quotation is this one? Anyone? This quotation actually is by somebody who is great and famous in India, or from India. This is Rabindranath Tagore. So he is a master teacher, right? So his quotation is this about education. Of course, he is the first non-European Nobel laureate in 1913. Have you seen the picture which is in the middle before? The Rabindranath and Einstein together. That's a young poet and that also has a good history. 1928, Tagore was visiting Berlin and he wanted to meet the famous scientist, Albert Einstein. Got a half an hour appointment, but the meeting continued for more than 2 hours. That has been recorded in books and articles and all. And what was the topic of a discussion? A poet from the East and a Nobel laureate poet and Nobel laureate scientist from the West. What was the topic of discussion? Anyone? Topic of discussion was Eastern and Western philosophy. Because Einstein believed that many of his ideas of relativity theory actually came from the Vedantic concept of Brahman, the abstraction. You see, special theory of relativity is an abstract concept, extremely abstract concept. It's a mind experiment, And he basically mentioned that many of the ideas came from reading the Vedanta, reading the concept of Brahman and the abstraction, because Brahman is the ultimate energy source, right? And Atman, which cannot be destroyed, neither can be created, same as energy, conservation of soul, conservation of energy. So that was the topic. So this is good to know, right? Okay, so maybe my final quiz and I'll finish it and take questions. Think about, you are all scientists and engineers or analytical minded people, right? You have a box over here, white box, black box, whatever you call it. There's a box, and this box has an input and an output. If you write algorithms, you also have an input and an output. Think about the box is an algorithm, box is a transformer, whatever. So think about, you have a small flower bud that goes as an input to that box, and you crank the box, magic box, you get a beautiful flower that you cannot take your stairs away. You could have a cocoon over here. You go through that box, you get a beautiful butterfly, right? What is there in the box? Okay, proper environment. What else? I want answers from everybody. Time. What else? Okay? Quick. Don't think too much. It must be that something is there, right? That makes this small flower bud the blue, beautiful flower. That cocoon becomes, right? I have a favorite answer. All of you are correct. I have a favorite answer. Once you see it, you can plug in your answer too. That's my university. That university is for that, right? You take young minds for energetic, they want to learn and eager to learn. They come unbaked and you make them a full baked product. You put Venkateswara University, you put your Amda University, whatever university you want to put, you put your favorite department there. And with that, thank you very much.